Problem statement from GATE Physics 2019 reads as follows. A 3-bit analog to digital converter is designed to digitize analog signals ranging from 0 volts to 10 volts. For this converter, the binary output corresponding to an input of 6 volts is. This is a multiple choice question with one correct answer, and you need to find the correct answer among these 4 options. First, let's look at what in as far as analog to digital conversion is concerned. What do we mean by resolution? So we have an analog input and we have a digital output. We know that much. On the left side you can see the input. In the red line you have minimum, and the blue is the maximum. Similarly, on the right side, the red is the minimum and blue is the maximum. And let's say this voltage is Vmin to Vmax, so the difference will be Vx minus Vmin between the input voltages. Similarly, the minimum output is 0. You cannot go below 0 as far as the digital input is concerned, and the maximum input, if it's a n bit convert, if it's an n bit signal, and the maximum value that you can achieve is 2 raised to the power n minus 1. This is the maximum digital, this is the maximum in the decimal value that you can achieve, right? So the difference between them again is 2 raised to the power n minus 1. Now please note that on the left, this is just a mapping that we are doing from an input to output. We are not creating anything out of the blue. So these two things should be the same. So whatever the difference between the minimum and maximum is, should be the same in both the cases, because it's just a mapping that we are doing. Now here it's important to define what do we mean by resolution. The resolution is minimum value that can be distinctly measured. This is the definition of resolution that we see in microscopy, and in fact in any other field that we see. As far as digital signals is concerned, that means the difference of 1 bit. So you can see, let's say when we are in green, right, when we are here, so let's say we have some let's say some whatever is the are the MSBs. Let's say the final 2 digits are 100, right? So the immediately next value has to be dash dash 101. Just the 1 bit change, that's all we should see. And if we are distinctly able to measure that will be the resolution. So 1 bit change in digital side is the resolution, right? And we know now that so we have, from in order to go from minimum to output, we have to take 2 raised to the power n minus 1 steps, and we all know that 2 raised to the power n minus 1 is nothing but Vx minus Vmin, which we established earlier. A simple unitary method tells us that one step will be equal to Vx minus Vmin over 2 raised to the power n minus 1, which is nothing but the resolution, because you have defined the resolution in such a manner that 1 bit change is the resolution. So this is the corresponding value in volts. Now we just saw that we can define the resolution like this, right? So let's just try to find the resolution for this problem. So I'll just put in the value. So it will be 10 minus 0 over 2 raised to the power 3 minus 1. So this will be 10 over 7. This is nothing but 1.43 volts. So we have obtained the resolution for this A to D converter is 1.43 volts. Now but here we'll introduce a concept ahead of resolution. We knew that one step is nothing but the resolution, right? We saw that in our discussion earlier. So we'll build on this concept now. So on the left we have the analog inputs, on the right you have the digital outputs. So you saw that inputs from 0 to 10, and since it's 3-bit output, so the minimum digital output will be 0 0 0, maximum can be 1 1 1. Max is, you can see, in violet, and the minimum is in the blood red color here. Now what will the first step? So the first step will be when we go from 0 0 0 to 1 1 1, and that we know will have a resolution of 1.43 volts. So on digital side, first step will be from 0 0 0 to 1 1 1. On the analog side, this jump will be, which we obtained as 1.43 volts. Now the second jump from 0 0 1 would be to 0 1 0. This is the next step. So this is 1, this is 2 if you convert it into decimal. Similarly, the jump here will be 2. You add 1.43 to 1.43, you'll get 2.86. Similarly, the next level would be 0 1 1 on digital side, and it will 4.29. Then it will be 100, 5.71, 101, corresponding level is 7.14, and the second last level is 110, and the corresponding level is 8.57. Obviously, if you go to the next step, which is 111 here, you will reach the 10 volts of analog input on this side. Now the interesting thing is that in the question asks that the level is 6 volts, so it will be somewhere here, right? This is 6 volts. So this is the analog input which we were asked to convert the digital output. Now it's clear that, let's say, if the input were here somewhere, then the output would have been 0 0 0. If the input were somewhere here, the output would have been 0 0 1. So if the input is 6 volts here, it has not crossed C. In order to reach 101, so you have to cross 7.14 volts. We have not crossed 7.14 volts. We have just got 5.71 volts. So 6 volts will correspond to 100. It's like a step function. So only when you cross 1.43, only when you cross 1.43, you will reach 001. Similarly, when you cross 2.86, you will reach 010, and so on. So it's like a step function like this, a ladder thing, right? So for 6 volts, since it has not crossed the 7.14 mark, it has only crossed the 5.71, the green level. So the output will correspond to the green level, which is 100 over here. So we have an option C which says it's 100. So option C is the correct answer, 100. Thank you for listening.